We're going to be looking at trig functions in the unit circle as well as with reference triangles. We're going to be using this information to determine different trig functions, whether it's the sine of theta of, sine of theta, what is that value based on a reference triangle, or if it's based on the unit circle. With that being said, this is a lot of information at once, but it's all based on triangles in which you're trying to figure out those different trig functions. Oh, come on, fish, I can do better than that. Let's say that I have my circle here, and I'm on the unit circle, right? So when I have a triangle, like I said in the last video, but kind of had some sound issues there. When you have the theta here, you technically have a right triangle. You have an X, a Y, and an R. If you are on the unit circle, that R value is obviously 1. Now, sometimes your triangle could be a little bit larger in the sense that you have a different value, and that's okay. You could just use Pythagorean theorem in order to figure out your different trig ratios. Based on the X, Y, and R, our trig ratios are a little bit different than our normal SOHCAHTOA. The sine of theta is Y over R. The cosine of theta is X over R. The tangent of theta is Y over X. And that makes sense based on our triangle there. Sine is opposite over hypotenuse. So opposite of our theta is that Y, and our hypotenuse is R. So if I wanted the other 3 trig ratios, obviously we just have the reciprocal there. So cosecant of theta is R over Y. Secant of theta is R over X. And cotangent of theta is X over Y. Again, looking at this, you technically have a right triangle, so don't forget that x squared plus y squared equals r squared. And that makes sense because it's a right triangle and based off of Pythagorean theorem. Now, here's how this information would be presented to you. You might have that the cosine of theta equals -5 over 13 with theta in quadrant 3. Okay, so the reason why this information is helpful is because this kind of gives us a base of where we're at. So if we have the cosine of theta, our x value is -5, and our r value is 13. So I'm not going to do this with the circle, but if I'm looking at it, -5 is over here, okay? 13, if I'm supposed to be in quadrant 3, 13 would be this measure. Went a little farther. So I need to figure out then what this y value is. And if it's in quadrant 3, I know that that y value has to be a -y. Your radius is always going to be a positive measure because whenever you square it, you're going to get a positive measure there. So we can use Pythagorean theorem in order to calculate what the y value should be. So we have -5 in parentheses squared plus y squared equals 13. Technically, yes, it's a negative, but I'm going to leave it like this and then just add the negative in from the end. So I have 25 plus y squared equals 169. Y squared is then 144. Y is 12. But again, because we're in quadrant 3, it's actually a -12. So based on this, now I can just go through and find all of my different trig functions. So sine of theta is -12 over 13. Cosine of theta, we already know. is going to be negative 5 over 13. Tangent of theta is negative 12 over negative 5, which would end up being positive. Yes, you can change that. Cosecant, reciprocal there. Secant, again, just the reciprocal. My recording guy's in the way. Cotangent is going to be a positive 5 over 12. So I used a reference triangle based on my coordinate plane, and then from there I used Pythagorean theorem, used the x, y, and r formulas for my different trig information in order to solve my trig ratios. Now, sometimes it will actually be based on that unit circle where the radius is 1. So some of the information is going to come out a little bit different, that it's not going to be necessarily a number without a decimal, and you're going to have to leave that information in terms of that square root. When it's based on the unit circle, they're going to ask you to find the sine value or cosine value or tangent, whatever that value is. So what is sine and cosine of 3 pi over 4? So since we are talking about 3 pi over 4, that means we're in radians. So to give you a basis, you might need to look at that in terms of degrees in order to figure out where that would be on the unit circle. Three pi over 4 is going to land you right here. So looking at that, something to talk about here is we're supposed to find our values for sine and cosine. Now, what that means based on the unit circle, this coordinate, which we know is x comma y, is going to be in the form of cosine theta comma sine theta. Okay, and we get that because if you have this measure here, this is your x, y, and r, cosine of theta is going to represent your x over r. So that's going to give you your x value, and that's based on that previous trig function. So when we're talking about finding the sine value of, or cosine value of an angle, you're really looking for the coordinate based on that unit circle. So we have the cosine of 3 pi over 4 and sine of 3 pi over 4. Now, you can convert your calculator into radian form in order to figure this out, but there's a little slight problem. If you don't have it in exact form, you're going to get a decimal, and some of you might not know those decimals, and I'll go through that in a little bit. But this one's a little bit easier. Cosine of 3 pi over 4 is going to result in square root 2 over 2. Now, when you're looking at this, notice on my unit circle that x is on the left. Therefore, this is going to be a negative square root 2 over 2. My sine value happens to be the same thing, but it's positive. So it's a positive square root 2 over 2. So let's talk about what decimals you need to memorize and know what they connect with. So whenever you're looking at this, you're going to get 5 different numbers when you're talking about the unit circle. You're going to get 0, you're going to get 1, and that's all positive and negatives of it. The other one that you're going to get is 0.5, which results in a half. That one's an easy one. You're going to get 0.707. If you have this as a decimal, it is square root 2 over 2. You need to know, obviously, if it's a negative, add in a negative. And there's one more that you need to know, 0.866. This is square root 3 over 2. You need to memorize these. And the reason being is because most people, when they type it in and they see that decimal, they'll write down the decimal, and I want exact values, or something else wants exact values. So you need to know what those square roots are. This is in terms of sine and cosine. There are two other decimals that you technically need to know, and that's based on the tangent values. 1.73 is the square root of 3, and 0.577 is square root 3 over 3. These you need to memorize based on the tangent values. So you could go through, and when it asks for those exact values, you could go through and type that in and figure out based on those decimals what the exact value is because of those decimals. So that's using your unit circle. We'll talk about how you can build the unit circle and get it memorized.